Hi everyone, welcome to learn the algorithm with me together. Today let's take a look at the 314 binary tree vertical order traversal. So what is this problem talking about? We'll be given root of a binary tree and then return a vertical order traversal of its nodes values. For example, like from top to bottom, column by column. And if two nodes are in the same row and column, the order should be from left to right. In here, few examples, and we can see what is the vertical order means. And let's move to this most complicated example because I want to also understand about if the nodes are on the same row and how should we print out the results, right? Like for example 3, we have the tree like this. Here is 1, 2, 4, and 10, 9, 3, 11, 5, 6, something like that. And now, which nodes are in the same columns? We can see that the node 4 is in the same column, in one column, and node 2 and 5 they are on the same column, and node 1, 10, 9, and 6 they are in the same columns, and 3 in the same columns, and 11 in the same column. And one thing we have to notice that is the node 10 and 9, how we are decided the order of them, right? And we can see that we should print out 10 first and then 9. So it means that if the node is on the left side, it should be print out first. So here is the result. First is 4, and then it's 2, 5, and then it's 1, 10, 9, 6, and then it's 3, and it's 11. This is how we should print out the result. And now the thing is how we can remember the orders, right? Not only about the orders, also we should remember which column and which row it is on. So first thing, I would love to give them the row and columns. For example, if we are traverse to this node, we should know its column is. So we will give each node a row and column so that we can remember which row and which column they are on. For example, for this one, we will give it the row is 0 and the column is also 0. And then when we move to the next node, we also will notice it is on the row 1 and the column is -1. And then when we move to another node, it will be the node for the row will be 2 and I can write like this 2, and then the column should be -2. And when you move to right, the row will be 3 and column -1. So now we exactly have the same column, which made them match together and ensure they will probably print together. And when we move to 10, we also need to know its row is 2 and the column is 0 again, because how we get the column is -1 plus 1 equals to 0. And then we go back to the 1 and go to the right side, and for it the row will be 0 plus 1 equals to 1, and 0 plus 1 also equals to 1, and then go to the left side, the column will minus 1 equals to 0, and the row will be 2. It's 1 plus 1, 1 plus 1, and then equals to 2 and 2, 2 and 0 because minus 1. And when we go to the right side, it will be 2 and 2. So every time when we go to the right side, the columns will plus 1, and go to the left side, the column will minus 1, and if we are going to next row, the row will plus 1. This is what we're gonna do, so that each node they now have the row number and the column numbers now. And then how should we like traverse the whole trees, right? As we all know, we know that there are two ways to traverse the tree. One is DFS, another is BFS. And now the point is, which one should we choose? And don't forget that we have a restriction. It's like when we are working on this node, we have to go to the left one first, and then go to the right one. And how should we ensure this order? Using DFS or BFS? So if we are using DFS, it will definitely like go left first, and then go right, and then go right, something like this. So yeah, probably we can like ensure this orders. But if we go to the BFS, let me think about that. Yeah, we will traverse the level by level. We also can ensure that we process the node 10 first, and then it's the node 9. And both these two can guarantee us like, if the DFS, we can just go left first and then go right. But for BFS, we definitely like level order already guaranteed it, right? And the second thing is we also consider is that we need to ensure the orders should be like 1 comes out first, and then it's 10, 9, and 6. It means that we also need to guarantee the from top to bottom. So here the first things we need to ensure is that it's left to right. This is the first thing. And next thing is top to bottom. So now DFS cannot guarantee us, because like if we go to 4, and then we are probably, if we continue to have nodes here and go here, and we may probably, because like we go to the left side if we can, and probably already go to this node already, and then go back to 5 and 6. Yeah, just like this. We go to 4, and then we go to 6 first, and then go back to get the 10. So the DFS is not an ideal way now. It can guarantee us like the top to bottom, and only the BFS, because it's a level order traversal. So definitely like we will traverse from top to level to the bottom. So we have to use the BFS to guarantee us the level order traversal. So now this is the initial idea, like how I will do. I will use the BFS to traverse the tree. But now the point is like, every time when we are working at current level, how we should add the node to our result, right? And now probably we use another data structure to help us. It's like a map. Why we need a map? The key should be our column, and the numbers, or probably I can say the key should be our column, and the values should be the numbers, right? So each time when I'm traverse like to this node, I should check whether the map already have these columns numbers. For example, like when I'm traverse, now let's go through the whole process. Why we need this? Because we want to print out like each column and numbers. So we should collect all the nodes which they have the same column together, so that we make a list is like this. Like we have the column here, and then we already know how many nodes in the rest, so that we can print out based on our column by column. And now let's write a pseudocode about our ideas. For the BFS first, we will have the queue definitely, and then we put the first node here. And of course for the BFFs, because we want to travel like level by level, we need to know the size of this level. Like this is the level 1, so the size will be 1. And now like we have a queue first, and then put root nodes into queue. And after that, when the queue is not empty, so we start to loop the queue. And first we also need to know the size of the level, so that we will know that like which level we are traverse, right? And then we start to put the node into it. So each time when we are putting a node, we not only need to know its value, we also need to know its row is 0 and column also is 0. And then we have also remembered the nodes here is the 1. And then we start to loop at current level. And first thing is we start to get the node, right? Or probably we just get this node, and we need to pop out it. When we got it, now let's make it here. We have more space. When we get the node, what we're gonna do next is we need to like calculate. We need to get its row and also column, and then we put node's value to the map based on the column, right? So that now we have like the column 0, we already have the value is 1. And then after that, we start to get its left node. So left node and right node. So if the left node is not null, what we do is then we are putting the left nodes into the queue. So we put the left node into the queue. And the left node we need to get is row will be row plus 1 and the column minus 1. So now the row will be like 1 and column will be minus 1 based on the current column and row to calculate it. And the value should be 2. So we put it in the queue again. And if the right is not null, then we put the right node into the queue. And so does this right node we will get is, probably we can see that, we get is row plus 1 and column plus 1. So now we'll get another node is, the value is 3, is this one. And what is row and column is 1 and 1, all based on its parent nodes to get it. And after this, we already like go through the first level and we go back to here and get the next level size, and the next level will be like level 2, and we have 2 nodes. And now we also get the node first. For example, we get the second node, and then we put the node value based on the columns. So now the column will be like minus 1 and the numbers will be like 2, and another one is 1 and the values will be 3, something like that. And then after we put this, we come back to, also we need to put the new left node and right node into it. So the left node will be like 4 and its row and column, something like this. And its right node of the node 2 is 10 and row and column. And so does the node 9 will be the row and column. So we just add each node from this order because we process the node 2 first and adds left and right to here. This is left and right. And then when we process 3, we put the node 9 and 11. So 11 will be here and row and columns, something like that. So then when we are process this new level, this is level 3. We will also add these nodes into our map now. Like for example, now at this level, we need to add the column as -2, and then we add 2 here, and also we are seeing the 0 again, so we just add numbers here, number 10 and 9, and then we are seeing this node at column 2, we add the node here is 2, 11. So this is how we will deal with the level 3, and etc. is doing this. And after we building this map, how we start to print out the result we want, right? And now we start to like print out our results. So we know that we can get the numbers, like probably we need to sort these numbers based on the columns. Like we have -1 and -2 is the minimum number, and the greatest is like 2. And when we sorted it, and we can start to get the numbers. But if we apply the sort algorithm here, that will cost us time. So why not just like when we are construct this map, we also maintain the number like the minimum column and the maximum column here. So that because all these columns just like at 1 or -2, -1, they are contiguous numbers, right? So here we can maintain, like, we can update our minimum column and update our maximum columns. So after all this, we can start to construct our value. Just like for now, we are starting. For now, start from minimum column to, probably we can say it's loop. Start column to start minimum column to the maximum column. So every time we just put the map to get the column and then put these values into our result, right? So after that, we can just return our results. Because this looping make us like starting from the minimum column, like -2 and then -1, 0, 1, 2, to build up our result. And this is the whole idea how I will solve this problem. And now the time complexity, because we traverse all the nodes, so the time is O n, and means the number of the nodes. And how about the space? Because we are like using BFS, we traverse like level by level. So it decided it is the OW. W means the maximum nodes of one level have. For example, like if this level has the most node, like it has 4, so the maximum nodes here will be like around like 4 or sometimes 5, something like that, because we still have the last node here. It has only the maximum nodes. So this is the most space we will cost. And yeah, that's pretty much for using BFS to solve this problem. And now let's move to the coding part. And now we have the tree node, something like this. And when we are working on the queue, we are using actually have the informations like row, column, and its current value. So we will use a integer rate to help us. So first we initialize the queue and we are processing the integer rate, and then we have the queue and using the linked list to implement it. And first we are getting the root nodes here. So the row will be 0, column 0, and the value will be the root node's value. And then we will also have a map, as I said, to help us to keep track of the integer, keep track of like at each column, like what kind of nodes it has. So the first integer means the column, and the list of integer means the nodes or the nodes values it has. And then this will be the column to values. We implement use hash map. And now we start to loop the queue using BFS, like when the queue is not empty. And first thing is we need to know the size of the current value. Size of the current level, so that we can traverse at this level, like starting from 0 and no more than the size. And first thing is we need to pop out the current node, or probably we can just say no, so type yes, and Q pull, and then we got the column row first 0 and column node of 1, and also the value we have is 2. And after this we also need a minimum column. Like at first we initialize a really large value, max value, and the max column integer dot min value. So now we also need to maintain this. The min column equals to math dot min column current column, and also the max column equals to right. So this is min column. And then we are putting we also need to update our map. Put the current column, and we are also like getting this let me think about it. Get the current column, get our default, because if it doesn't exist before, we need to initialize a new array list. And this is the column and new array list. And then after we get that, probably so probably we need to do it like this. And list integer column list dot add column value into it. And then because this value will return true or not, so we cannot just directly to put it into here. We will do something like this. And then after we put this, we can start to like handle the children of the current nodes. So if the current, alright, so that's the problem. Like we cannot just use the integer because we lost the current node now. So now we need the node info instead of the integer array. Class node info. Like we need to know row, column, and also the tree node information. And have a constructor node info int row column tree node something like that. So this row equals to row, this column equals to column, this node equals to node, something like that. And the fourth is we need to offer now is node info is 0, 0, and the root node. And now we have to get the node info now. The row will equals to node.row. We don't have to say this now. We can just get node.column, node.column, and then we are putting the node.column into it. So now it's the node.tree node. Dot left or we have to say tree nodes. No info. Here node info, and so that's node info now. So now node info dot node dot left, and we can have this tree node dot node, and then current node dot left is not none, and then we are putting this new node into the queue. Offer new node info includes the row +1 and column -1, and also the node dot left. And how about the right nodes here? If the right node is not known, we'll also row +1 but column at 1, and then offer the right node into it. So that's pretty much how we are working on the BFS part. And after we construct this map, we are starting to go through the whole map to build up our result list, max column here, and then I++. So now we need to have a result list, array list, and now the result will add this one dot get the column, and after all this we just return the result. So that's pretty much we want to do, and I'll just run it. Oh wait, cannot find some. Yeah, the column now becomes to no info dot column, and now it's the node dot value here. Hold on. Node dot info dot row, and also node dot info dot column. Oh wait, integers. Oh yes, the result should be like a nested integer. Cool. Now so every test case passed now, and yeah, I believe that's pretty much how I will work on this problem. And also, like, if the root node is a null, we can just return null list at first. right? This is something corner case we can check. And just return the results. Cool, and let's submit it. Cool, so now all the test cases passed. And how we work on this problem is like, first we are using the BFS because it will guarantee us like the left to right order and also the top to bottom orders. And the second is we use an extra data structure here to help us to remember like each column, it will have what kind of numbers we have. And then we also use a minimum column and maximum column to help us to remember like how we can like construct our results based from the left to right, so that we don't have to use the sorting algorithm or something like that to sort our keys in the map. So this is how I will solve this problem. If you think this video helped you, please give me a thumbs up. That would be great encouragement for me. And thanks for watching. See you at next video. Bye.